So this week we're going to talk about finding percentages. So why do we calculate percentages and why are percentages useful in chemistry? So let's start with something we all know, like quiz grades. So let's say Wally gets a 15 out of 17 on a quiz and Kenny gets a 45 out of 51 on a test. Which one got a better grade? It's tough to say, really, right? So let's talk about percentages first. So what's the word mean, a percentage? It starts with the prefix per, which means one or in one. And cent should remind you of a penny or a century. And it does because a cent means 100. So when you stick them together, a percent means let's work in 100s. So we saw before that Wally took a test that was out of 17. Like, that's tough. So what if we took his test and scaled it up so that it was out of 100 points? What would his grade be? As a culture, we decided to measure things out of 100. We could have made per decages, and that would mean that we're measuring things out of 10, but we didn't. And we could have made per millages and measured things out of 1,000. And if you're a baseball player or a softball player, you might realize that we do. If a batter has an average of 310, that means that that batter on average in 1,000 plate appearances will get 310 hits. It doesn't mean that the player will ever have 1,000 at bats, and it doesn't mean that the player has 310 hits. What it does mean is that if we scaled up however many hits and however many plate appearances they have right now, if we scaled that up to 1,000 plate appearances, how would they do? So a batting average allows us to compare how well batters are doing, even if one player has played like 27 games and the other player has played 58 games. It allows us to compare things that appear different. So let's get back. So let's take a look at Wally. He got a 15 out of 17, and we need to figure out what percentage he got. So there's a couple ways to do this. One of them is using ratios. So let's say here that, let's go back. Let's go back and say Wally has got a 15 out of 17. So how do we convert that into a percentage? So we're going to take his score out of the total score, and we don't know what his grade was, like right here. So let's click that thing, get a pen. We don't know what his grade was out of 100. But if we cross multiply there, so let's cross multiply, 15 times 100 will give us 1,500. And 17 times the question marks will give us 17x. So now we're left with this equation, 1,500 equals 17x. We need to get x by itself. So in order to do that, we'll divide both sides by 17. 17 and 17. Over here, the 17s will cancel, and we get 1,500 divided by 17 equals x, or x equals 88.2%. Wally got an 88.2%. If you don't like ratios, there's a way to do it with a formula. Formula says that a percentage is equal to whatever part you are interested in divided by the total amount. So we're students, we're teachers, we're interested in how much did you get right. So Wally got 15 points right out of 17. So the total amount on the test was 17. He got 15 right. So we'll put it in the formula, 15 divided by 17, or 15 over the total times 100, and you will get 88.2%. We get the same answer because essentially they're really the same method. The ratios and the formulas are exactly the same. So look, when we get here, we took our ratios and we said 15 divided by 17, and we wanted to convert that into something out of 100. And we cross multiplied. When we did that, brought the 100 over, we will get 15 over 17 times 100. Well, that's just this right here, right? 15 over 17 times 100 is what we just did with the ratios. So it's not a matter of which method is the right way. It's just a matter of which method makes more sense to you. So we've talked about what Wally got. He got an 88.2. What'd Kenny get? Well, using the ratio method, we'll say that Kenny got a 45 out of 51, and we want to convert that into what he would have gotten if the test were out of 100. So we're going to cross multiply and cross multiply, and we'll get 45 times 100 divided by 51 equals, hey, 88.2% again. Wait a minute, how's that possible? They both got the same score? Yeah, they did. Because if you look, Wally got 15 points and Kenny got 3 times more than that. Oops, that's an ugly 3. So he got 3 times more points than that. But Wally's test was small. If you multiply 17 times 3, you'll get 51. So really, they got the same score because Kenny's test was just 3 times larger. And so he got 3 times as many points. The ratio of points to total points is the same in both cases. So why do chemists use percentages? It seems weird, like it's great for batting averages and for figuring out your test grade, but why would we use it in chemistry? So let's say a puddle has 5 grams of water in it. Last week we were figuring out how many moles of water were in that puddle. Now we want to figure out, well, if I could tell you that that puddle of water was 89% oxygen, and you knew that there were 5 grams in there, you would be able to figure out how much oxygen was in there. Or if you wanted to know, like, oh, I've got this 5-gram puddle, but you don't know how to figure out what the percentage is, you can easily calculate it. So before we jump into chem, let's take a look at things that we're all pretty familiar with, and we'll take a look at food. So I'm going to show you a short video about a banana, and we're going to try and figure out what percentage of a banana is edible and what percentage of the banana is the peel. Now, I'm sure some of you eat banana peels, but let's assume for a minute that banana peels are inedible. Okay, take a look. Figure out what percentage of a banana is actually just the peel. Like when we eat a banana, how much of it are we actually eating? So we'll turn on the balance, let it zero itself. Okay, and a whole banana with its peel, in this case, is 141 grams. And then we're going to peel this banana. So we're peeling the banana, and in this case, I only want to know what percentage is the peel. So I'm going to get rid of the banana itself. I'm going to eat that later. Here we go. Let's put that off to the side, and here we just have empty peel. And the empty peel weighs 55 grams. So what percentage of the banana is the peel? Okay, so from the balance, we learned that 141 grams was the entire banana. And then I reweighed the peel, and it was just 55 grams. So what percentage of the banana is the peel? We can do it with a ratio. We can say that 55 grams of this banana over here was the peel, the inedible part, and the total amount of the banana was 141. So if we cross multiply, we will get 5,500 equals, so if we did this, 5,500, oops, let's go back here. So erase that, let's start again. So 5,500 is equal to 141x. And to get x by itself, we're going to divide both sides by 141, which will leave us right here, 5,500 divided by 141, and that is 39%. So a banana is 39% peel. Now, if you wanted to use the formula, then you would say, well, my percentage is the part that I'm interested in, which in this case is the peel. So I'm going to take my peel's mass and put 55. And divide it by the total mass of 141, and you get 39% again. So let's turn it around. We know that the banana is 39% peel. What percent is edible? What percent is the actual banana that we eat? So first thing we need to know is how much of that banana was the eating part, the banana itself. So if we know that the banana is 141 grams and the peel is 55, we can subtract them to figure out that there's 86 grams of edible banana. And then we can just use the formula and say, well, if I'm interested in the edible part this time, I'm going to take 86 grams divided by the total and get 61%. Now, some of you are thinking, well, duh, right? There's a quick way to do that. All percentages add up to be 100. So if the peel was 39%, then we can just subtract that from 100 and say, well, the edible part has to be 61%. So if you can recognize those kinds of things, do it. It makes the math a lot quicker. There's one more thing that we're going to need to know, which is what if a problem gives you the percentage and then gives you the total amount of points, or gives you the points that you scored? How do you use the percentage in a formula? So let's use ratios this time. So let's say Lexi gets an 85% on her test, and she knows that the test has 60 total points. So we know the percentage is 85%, and we know the total amount of points. So this time, we know that Lexi got an 85 out of 100, and I know it's 85 out of 100 because it's a percentage, and that always means it is out of 100. And we want to know what Lexi got, so the question marks, out of a total of 60 points. So we're going to cross multiply, and that gives us 85 times 60. And when I cross multiply the other way, that gives me 100 times x. If I divide both sides by 100, here we go, that will give me x equals 51. I can do it using the equation method too. This time I know that Lexi got an 85%. So I fill that in as my percentage. I'm looking for how many points that she actually got right. And I know that, a little typo here. This is a 60. So she got a 60. When I cross multiply, I then get 85 times 60 equals 100 times the question marks. And in this case, I'm changing those question marks to x. So x equals 51 again. So no matter what you get, whether you get the parts and the total, or whether you get the percentages, you can do some math to figure out how to solve the problem.